So now let's look at more examples to see how we can use the fundamental theory of calculus part 1 to compute the definite integral. So the first example, the integral from 1 to 2 x squared times dx. So it's equal to, we need to find the antiderivative, right? The antiderivative for x squared, that means you need to find a function whose derivative equals x squared. So we use the power rule, which is x2 plus 1 2 plus 1 over 2 plus 1, right? Then evaluate at 1 and 2. So it's equal to x cubed over 3. Then evaluate at 1 and 2. So it's equal to, if you plug in 1 and 2, so this would be 2 cubed over 3 minus plugging 1 cubed over 3. So this would be 7. This is 8 minus 1, so it's 7 over 3. So now let's look at the second example. The integral from 0 to pi over 4 of cosine x dx. So we need to find the antiderivative of cosine x. So whose derivative equals cosine x? The sine x. Then evaluate at 0 and pi over 4. So we should plug in the upper limit first, right? Sine pi over 4 first. Then minus, plug in 0, the lower limit. So it's equal to sine pi over 4 is 45 degrees. So it's square root 2 over 2, right? Minus sine 0 equals what? Equals 0. So it's square root 2 over 2. So now let's look at the third example. The integral of from 1 to 4 of 3 times square root of x dx. The first thing, we can use the properties of the definite integral. We can take this constant 3 out. So this would be 3 times the integral from 1 to 4 and the square root of x dx. Okay, then we use the power rule again. So what is the square root 3? The square root of x. Square root of x is x to the 1 over 2. So we write it as a power form. Then we can use the power formula, right? Power rule. So this would be 3 times what? Times x to the 1 over 2 plus 1 over 1 over 2 plus 1. This is the antiderivative of x to the 1/2. Then we evaluate this antiderivative at 1 and 4. So what does this mean? This means it's equal to 3 times, we use some bracket to group the difference, right? We plug in 4, so this would be 4 to the 3 over 2 over 3 over 2. 1/2 plus 1 equals 3 over 2, right? Then plug in 1 to the 3 over 2 over 3 over 2. If you do the calculation, you will see this one is equal to 14.